In this example, we're going to compare fractions with the same numerator. So in the last video, we were comparing fractions with the same denominator. Now we're going to look at this from a different perspective. Identify the fractions represented by area shaded in the rectangles below. So in this first rectangle, we have 3 equal pieces and 2 pieces are shaded. So we have 2/3. This rectangle is broken into 4 pieces, and we have 2 of them shaded, so we have 2/4. In this rectangle, we have 1, 2, 3, 4, 5, 6 pieces, and 2 pieces are shaded, so we have 2/6. And finally, we have 1, 2, 3, 4, 5, 6, 7, 8 equal pieces, and 2 of those pieces are shaded, and we have 2/8. So now we want to order the numbers from least to greatest by comparing the amount of the unit area shaded. And you may notice as you move down these rectangles, you have a smaller amount in each case. And again, think of this as maybe a tray of brownies. Here you had the most of the tray compared to the others. Okay, this is the second largest amount, the third, and this is the smallest amount. So the smallest, so we start with the least, is 2/8, then 2/6, then 2/4, and then 2/3. So these are the fractions ordered from least to greatest. And let's stop and take a minute to look for patterns. So remember, this was comparing fractions with the same numerator. In each case, you had 2 pieces, so you have a numerator with 2, but the denominators are all different. And it looks like the bigger the denominator, the smaller the number. So notice here, we go from 8 to 6 to 4 to 3. These numbers are decreasing, but the fractional amounts, the relative amount of the unit shaded, is increasing. Okay, so this is because the more pieces you cut it into, the denominator, the smaller the pieces. So if you have the same amount of pieces, but the pieces are different sizes, the bigger the pieces, so 2/3, the bigger the amount of the unit. Let's look at the next example. Identify the fractions represented below. In each case, the unit is all the stars in the rectangle. So for this first one, we have 4 stars and 3 of them are shaded. So this represents 3/4. Here we have 1, 2, 3, 4, 5, 6, 7, 8 stars, and 3 are shaded. So we have 3/8. And finally, here there's 10 stars, and we have 3 of them shaded. So we have 3/10. Next, we're asked to order the numbers from least to greatest by determining which fraction has the largest fraction of stars shaded relative to the total number of stars. So notice this is bolded and it's in italics. So I want you to think about this. So looking at this, each of these, it's not like the last example where we could compare how much just by looking at the relative areas. Each one of these has 3 stars, and the 3 stars are all the same size. Okay, so let's try to think of this in a different way, because remember what fractions are describing. They're describing a relative amount. Okay, so let's think of this. You have a friend, and your friend has all these stars, and the stars are worth $1 million each. Okay, so in this case, your friend has 4 stars and gives you 3 of them. That's a pretty good friend. Okay, your friend gave you more than half of the stars that he or she had. Here your friend, and that would be 3 million, but relative to the 4 stars, that's a large amount. Now here your friend has 8 stars, so maybe 8 million, and gives you 3. So you're still getting 3 million. Relative to the 8, you got less than half of the stars that your friend had. Still a great friend, but not as giving as this friend. And then finally, here your friend has 10 stars. 10 million, they give you 3 million. Okay, still a great friend. We're not going to give up this friend for anything. But compared to the total amount the friend has, this would be the smallest relative amount. Okay, so looking at the fractions, it's going to work just like the last problem. The numerators are all the same. Okay, but relative to the total amount of stars in each picture, the larger the number of stars, the smaller the number. So 3/10 is the smallest, then 3/8, and finally 3/4. Now we're going to look at an example with a number line so we can think about negative numbers. Okay. Plot the following fractions on the number lines. Label your points below the number lines. Okay. So first we're going to plot 2/3 and -2/3. These have tick marks on them already for us. So these are broken into thirds. 2/3 would be right here. And -2/3, its opposite, would be over here, or you could think of it as -2/3 in the negative direction. Now we have 2/5 and -2/5. Well, here's 2/5. This is broken into 5 pieces. And -2/5. And finally, we have 2/8 and -2/8. This is broken into eighths. So this would be 2/8. And this would be -2/8. Okay. So we've labeled the points, and now let's order them. So I'm going to order them from least to greatest right up here. Okay. So from left to right, so we're going to look at these moving from left to right, and whichever one we hit first from left to right, that's going to be the smallest. So the least number is -2/3. So let's kind of check these off as we go. Then moving along, the next number would be -2/5. The next largest number would be -2/8. Okay, now we're moving to the positive numbers. The next number is +2/8. Then 2/5. And then 2/3. Okay. So we're going to summarize this on the next slide, but let's just take a look. Okay. So if we think of these as all having numerators of 2, these numbers are negative. Okay. In the negative direction, the larger the numerator is, the smaller the number is. Okay. And again, that's because 2/3 is larger than 2/5. But if we reflect it across 0 and take the opposite, it's going to be to the left, of -2/5. Okay, so for the negative numbers, the smaller the numerator, the smaller the number. And then when we get to the positive numbers, the smaller the numerator, the larger the number. Okay, so let's summarize that on the next page. If two fractions have the same numerator and the fractions are positive, then the fraction with the blank denominator is greater. So let's just write 2. So same numerator, they're both positive. Okay, this one is greater, and it has the smaller denominator. If two fractions have the same numerator and the fractions are negative, so let's compare -2/3 and -2/5. Remember, this reflects these numbers across 0, so this number is going to be larger. So then the fraction with the larger numerator is greater. And as always, if one fraction is positive and the other is negative, then the positive fraction is greater. Okay. Now it's nice to have these summaries, but I just want to state that you shouldn't really memorize this. Okay, this can be confusing to memorize. We're using the words smaller and larger and less than and greater than. You should really try to understand the concept, and I think the best way, especially for including negatives, is try to imagine where they are on the number line. So you don't need to always draw a number line. You can picture one in your head, and you can try to think of, well, -2/5, that would be closer to 0 than -2/3, and then you can think of the ordering.